Okay, so let's start with number 11, since Gavin had questions about that. So you have Huey, Dewey, and Louie. So here's the most important part of this story. What's the initial momentum of the system?
Zero.
Zero. They have mass?
Yes.
Yes.
Yes. They have inertia?
Yeah.
Absolutely. They just don't have momentum. Now, the other part of this is that all of them have the same mass. So you can look at the momentum of Huey plus the momentum of Dewey plus the momentum of Louie has to equal the new momentum of Huey plus the new momentum of Dewey plus the new momentum of Louie. All momentum problems start the same way. Okay? They all start the same way. So they're all at rest, so all of this over here is zero. So what that means, at some point later on, all of these values have to add up to zero. So in the first situation, Huey's at rest and pushes Dewey towards Louie. So the only way momentum can be conserved is if whatever momentum Huey has, if you want to make that some positive momentum, then what do you know about the momentum of Dewey?
Same but negative.
Yeah, it's going to be a negative number, but the same value, so that that all adds up to zero. Okay? Select the two cards. So, then on C, if Dewey, so then afterwards, then Huey pushes off Dewey, and we got that, and then Dewey comes to a stop after he pushes off Louie. So then, imagine this, Huey is going this way. Huey is lost in space, okay? He is gone, he's in space. There is no way he can change his momentum.
Yikes.
Dewey runs into Louie, and then Dewey stops. So then if Dewey stops, how much momentum does Louie have?
The
Same
amount that
momentum.
Dewey
The
had.
same amount that Dewey had. So basically, Dewey's going to be stuck in the middle, Louie is going to be going this direction, Huey's going to be going this direction, and they'll never meet again.
Kind of like a Newton's cradle.
Huh?
It's kind of like a Newton's cradle.
Kinda.
He goes this way. He stays in the middle, and then he just goes away.
Yeah.
Wait, so Dewey's still moving though? Or no, Dewey's
No, Dewey stops. So Louie's going this way, Dewey stopped in the middle.
Oh, I figured out C.
So is
Yeah.
Louis in C, does Louis have 2 times as much?
Yeah.
No, because they all have the same mass.
Well, no,
Okay.
relative to Huey, right? So it'd be like.
So everything still has to add up to zero, right?
So,
Yeah.
So
So
the
Huey and
momentum
Louie
of
are
Huey
opposite on C.
after the initial push hasn't changed. That's still the same value. Dewey's now momentum is zero because he's stopped.
Mm-hmm.
So the only way everything can still add up to equal to zero
is if his is the
if Louis
opposite.
takes on the momentum of Dewey.
So is equal but opposite in direction of
I
the
can live with
explanation.
Where I was going.
I can do that. Okay, let me give you some hints. So on number 10, because if your answer to 10A is wrong, everything else is going to be wrong.
Oh.
So here's the setup on number 10. You got an inclined plane, you got a block of wood. Now, this is frictionless, so you don't have to worry about your force normal or anything like that. The only force that's going to make it accelerate is your force parallel, which you can find using FG sine theta. Now, I've given you the weights of the blocks, so how are you going to find the mass of the blocks?
Divide
And
by.
equal.
Right, divide by 9.8
Yeah.
meters per second squared. So you got the 24.5 Newton block, boom, it's sliding down. So you got to find the accelerator. First you got to find the net force, then you have to find the acceleration, then you have to use that equation. So your answer to 10A is going to be a little bit above 3 meters per second. Okay? Because if that's wrong, everything is going to be wrong. Okay? It's going to be 3 and some change. Now, you get down to the bottom. Now it turns into a California problem. So they're going to hit and they're going to move off together. So these all start the same way. Momentum of 1 plus the momentum of 2 equals the new momentum of 1 plus the new momentum of 2. So over here, because they're moving off together, you can combine those masses and find that new velocity. So your answer to 10B should be around 1 meter per second, okay?
Not
How
two.
close?
Huh?
How
Not two.
close?
No,
Would you get on two?
much closer to 1 than 2.
Okay.
Now, when you get to C, why did I have to, when I typed this up, why did I have to make the force friction
what
a
I did wrong.
negative value?
Because it's resisting it, it's going.
Yeah, it's in the opposite direction. You have positive velocity. I'm not gonna stop something by applying a positive force to something with a positive
Yeah.
velocity. So there's a couple of ways you can work C. You could go old school, F equals ma. You know the force. Now, your mass has to be the combined mass of both objects, because they're both moving off together. You can find the acceleration. Once you get your acceleration, then you could go, oh, v equals v naught plus at.
Yep.
Take your acceleration, put that in there. You know your final velocity is going to be 0. Now, your initial velocity, watch this, that initial velocity has to be your answer to B, not your answer to A. Okay? Because that's how fast it's moving when the frictional force starts to act. Okay?
Oh no, I did this one wrong.
So the other option is that if you like this idea of change in momentum, you can go force times time equals change in momentum, which is mass times v minus v naught. And you do the exact same math, you just change the sequence and how it looks, but you get the exact same answer. Then on D, there's a couple of ways you can do D. You can use that equation. You could use distance equals 1/2 v plus v naught. There's a whole bunch of different ways you can do D. So this is an ish, okay? This is an ish. But all of your answers on 10B through D are around 1 meter, around 1. Okay? It's an ish, but they're all around 1.
I think plus or minus
How much?
0.6-ish.
Yeah.
That's a big ish, but yeah.
Wait,
Okay.
There is,
Plus or minus
the biggest answer
0.56.
mathematically on B through D will be C.
Okay, yeah.
okay. So like 2.56.
Oh God, no.
No, I'm just kidding. I'm just kidding. Like
God,
1.56.
What'd you for D, Dylan? Good. Good work.
You didn't think I had D on here, did you?
I didn't know what it was.
No, yeah.
I
Yeah, I
threw,
ran
I
out
threw
of
it, yeah.
Your
Okay, that's
answer
base.
to number 6 on the ones that I typed up
Oh.
should start with a 6.
Yippee!
You did with like a
2.
meters per second.
Oh.
I'm just telling you, it starts with a 6.
I guess it's
Your answers on 7 and 8
Buddy,
would make not so good GPAs.
are we taking Chem 2?
Can you have a negative GPA?
Well, I'm just telling you, these are the
Oh, okay.
numeric values.
Chem
Okay.
1?
I'm not worried about the sign.
What'd you have?
I mean, I was in there, but
Okay,
Yeah, nobody was.
are you good on those?
Yeah.
Any questions on the ones out of the book?
12. Oh wait, those aren't in the book, but 12. What'd you know 12?
It's multiple choice.
Nothing. I didn't know how to do it. Because
Oh.
I kept trying and trying, but I just kind of never got an answer. That was an option, so I just stopped trying, and I'm like,
Okay, so the whole key to this is that they're moving in opposite directions, right?
Yep.
So you have that smaller one m moving with velocity v.
Yeah.
That's its momentum, right?
Yes.
Now, the other one's moving in the opposite direction. So that's going to be 3m times
Negative 3.
negative 3v.
Oh wait, what? Wait, what?
Wait,
Why-
what?
because they're in
is-
opposite directions.
Why is it negative 3?
Because it's in
Because if
opposite
you define
directions.
the smaller m to be positive, the other one has to be a negative value, and it says moving with velocity negative 3 meters per second.
Oh, so why'd you put 3v?
He put negative 3v.
Like, why'd you put the v? Why not meters per second?
That's the
Wait, so is that v1?
Yeah, you could put it, I just,
Gavin, look.
If you wanna put it in terms of 1 meter per second, you can, it's gonna all work out and be the same. Yes, you could take m times 1 plus 3m times -3 meters per second. It's gonna be the
That's what it
exact
is.
same thing.
What?
It's basically MV plus MV, right?
Okay, continue.
So on this side, I'm gonna have -9 MV plus m. So what are you gonna get?
Minus.
Now, here's the whole key to this. After the collision, the block and plate are stuck together. So after they're stuck together, right,
Yeah.
then excuse me, this is the one you don't know. You don't know this value. That's
Yeah.
the V that you
Yeah,
don't know.
that's what I was wondering.
That's the V that you don't know. But because they stick together, you have 3m plus m, and that's what's moving at 1 meter per second.
Okay.
So then you can solve for that V. Since you know what these values actually are. So you get MV,
So that V is just like a whole nother variable? That's
yes,
just the initial.
and that's what you're trying to find.
Okay.
If you don't like the M's, pick a mass, make it 1 kilogram. So then you'd have 1 kilogram and 3 kilograms.
Oh yeah, because the M's end up canceling out anyways.
Yeah,
Okay. Okay.
okay.
Why do we put letters so like confusingly? Like, why is period T and magnitude T instead of just like M and T? Makes me.
Well, because
it
little t
hurts my
is just
brain.
like a time when you run, like if you run between 2 points. Uppercase T, we use that to indicate that it's gonna like an orbital period, it's gonna return back to the same point. So it's just, if there's still time, but once you see big T, you know it's coming back to that same point.
I thought I get a D.
Okay,
Hang on. Wait. -10 V
I did not
over
get
4
negative. Oh,
1 meter per second.
anything
that's
else?
Not what I got.
On that problem 20 out of the book, that answer should be around 30 kilograms.
Huh? Oh wait, which 20?
Problem 20.
Dylan?
There's two 20s.
No.
So
No,
Problem
problem 20.
20, not question 20.
Look on your paper, it literally says problems and questions.
Yeah, buddy.
same thing.
Not really.
No, not really.
Questions have like multiple choice or like a written answer.
Yeah. Okay, anything else? Going once, going twice. So,
Dylan, what'd you get on plus?
Oh, in the book.
I
So
got,
Vanessa, stop that
I didn't
camera,
get
please.
anything as an option.